Okay, so we're going to continue reviewing the idea of solving rational equations. Now remember, to solve a rational equation, the first thing you're going to do is you're going to factor all denominators. Then you're going to multiply both sides of the equation by the least common denominator. And the purpose of that is to eliminate the fractions. Then you can distribute and combining in like terms. You're going to isolate the variable. And then you're going to verify that your solutions is or are not restricted. Okay, so let's look at number one. So number one, first thing you want to do is to make sure that these denominators are factored. So first of all, they're monomial factors, so you cannot factor that any further. So this is 1 divided by 1, this is y squared. So you have monomial factors. So the next thing you're going to do is you're going to find the restrictions. And remember, you cannot divide by 0, right? So for example, if you have 8 divided by 0, the denominator cannot be 0 because that's undefined. And so whenever you have a rational expression, you would need to ask yourself, when you're solving a rational equation, you need to ask yourself, what makes the denominator 0 when you have variables in the denominator? So since these are monomial factors, that's a pretty easy thing to determine. What makes this denominator 0? Well, when y is 0. So the restriction is that y cannot equal 0 because y divided by 0 is undefined. And the same thing here. What makes y squared 0? Well, y squared 0 when y is 0. So there's only one restriction. Next thing you're going to do is going to find your least common denominator. So you have three fractions. You see that? You have 1 divided by 1, 5 divided by y, and then negative 6 divided by y squared. So the least common denominator is y squared. So you have to use the factor, you have to use the exponent that occurs the greatest. So it'll be y squared. So this is one factor y, this is two factors of y, so you need y squared. Okay, so now you're going to multiply both sides by the least common denominator. So notice that on this side you have two rational expressions. I'll put that in parentheses. So I'm going to get y squared times 1 minus 5 divided by y equals, and then negative 6 divided by y squared times y squared. So I multiply both sides by the least common denominator. Then you're going to distribute to get rid of the parentheses here. So you have y times 1, y squared times 1 is y squared, minus, and then y squared times the second fraction, which is times y divided by 5 divided by y, equal. And over here, I'm going to just go ahead and divide these out. You remember the whole purpose of multiplying both sides by the least common denominator to get these denominators to be factors of 1. So notice that since I reduced here, this is now a factor 1. So this is negative 6 divided by 1 times 1, which is negative 6. And then reducing over here, see, this is one factor y, right? You have two. So when you reduce, you're left with one factor here. And so you get y squared minus 5y equal negative 6. All right, so notice I clear the fractions. You don't see any fractions any longer. But notice that you now have a quadratic equation. So you need to solve this quadratic equation. So you went from a rational equation to a quadratic equation. And so to solve this quadratic equation, for us, they're going to be factorable. So you got to bring this in standard form. So I'm going to get y squared minus 5y plus 6 equals 0. And then factoring, we get y minus 3, y minus 2 equals 0 times y minus 2 equals 0. So this trinomial factor is this. And then remember, you're going to set each factor equals 0. That's a zero factor property. So I get y minus 3 equals 0. Y minus 2 equals 0. And then I went from a quadratic equation to two linear. And so here I get y to be 3, y to be 2. So those are your proposed solutions. Remember, you have to always check to see if your proposed solutions is any of those restricted values. So go back and ask yourself, are any of these a restriction? And the answer is no, because the only restriction was 0. All right. So if I did all this work correct, then these would be your solutions. So your solutions, so these proposed solutions actually do work. So it'll be y equal 3, comma, y equal 2. All right. And you can always check. So if you want to check, always go back to the original. Now, I'm not going to have time to check all of these, but just remind yourselves how to check this. Here's the original. So the original is 1 minus 5 divided by y equal negative 6 divided by y squared. So let's check the first one, x equal 3. So in place of, that's y, sorry, y equal 3, excuse me. y equal 3. So in place of y, I'm going to substitute 3. So I got 1 minus 5 divided by 3. And we see that's going to equal negative 6 divided by 3 squared, which is 9. All right, so let's see what we get. 1 minus 5 thirds. Now you could do this in your head because that's just a 1. 1 minus 5 thirds is a negative 2 thirds, right? Negative 2 thirds. And the negative 6 ninths reduced is also a negative 2 thirds. So they're equal. Okay? And then you would do the same thing with the other one, and that would check out as well. All right, so notice that this rational equation had two solutions. None of those were restrictions. All right, let's look at number 2. Number 2. In number 2, we have this rational equation. And so I have this trinomial. And so let's go ahead and factor this trinomial. So, and I can factor this as these two factors. So it'll be x plus 3 times x minus 4. Right? And when you fall it out, you get this back. And so the restrictions, so you need to ask yourself, what makes this factor equal to 0? Because whatever makes this 0 makes this undefined. So negative 3 plus 3 is 0, right? So x cannot equal negative 3. What makes this factor 0 when x is 4? What makes this factor 0? Well, that's all negative 3, already taken care of that. What makes this factor 0 when x is 4? So there's only two restrictions. Then you got to find your LCD. So the LCD has to include every factor you see. So I see an x plus 3 and I see an x minus 4. And now you're going to multiply every fraction by that LCD. So that's the same thing as saying multiply both sides by the LCD. So every fraction be multiplied by the LCD. So you're going to say the LCD times the first fraction, the fraction on your left-hand side, and write it in factored form. So it'll be x plus 3, x minus 4, equal the LCD times this fraction, x plus 3, x minus 4, times 3 divided by x plus 3, plus the LCD times the other fraction, 5 divided by x minus 4. Now remember, the whole purpose of multiplying both sides by the LCD, which technically you're multiplying every fraction by the LCD, is to clear those denominators. Get those denominators to be factors of 1. So these divide out. X plus 3 divides with this x plus 3, and the x minus 4 divides with this x minus 4. So see, you have factors of 1. So that in effect, you cleared the fractions. So I have x, this is 1 times x squared minus 6, so you get x squared minus 6 equal. Over here you get 3 times x minus 4 plus, and then 5 times x plus 3. Okay? Distributing, I get x squared minus 6 equal. There's going to be 3x minus 12 plus 5x plus 15. Combining like terms, I get x squared minus 6 equal 3x plus 5x is 8x. A negative 12 plus 15 is a positive 3. So notice I have this quadratic equation. So I'm going to bring all the terms to one side. So when I do that, I get x squared minus 8x. A negative 6 and a negative 3 is a negative 9 equals 0. So when I bring all the terms to one side, this is the trinomial I get. Now I'm going to factor this. So I'm going to factor this quadratic equation. I'm going to solve this quadratic equation by factoring. So I get x minus 9, x plus 1 is going to be equal to 0. Then I'm going to set each factor equal to 0. And so I went from a rational equation to a quadratic equation to two linear equations. So x equal 9, x equal negative 1. So these are my proposed solutions. Remember, I'm using the word proposed solutions. But I need to check to see if these proposed solutions are any of the restrictions. And so notice that these are not any of these. So if I did this work correct and I substituted into the original, then the left side will equal the right side. All right. So, and I did do the work correct. So these are the solutions. So solutions equals, you're going to say x equal 9, x equal negative 1. So let's just check one of them, just to show you how to do that. So let's check x equal negative 1. So we go back to the original, And so the original, here's the original. You have x squared minus 6 divided by x plus 3 times the x minus 4 equal 3 divided by x plus 3 plus 5 divided by x minus 4. So in place of, so remember, I'm just checking this one. So in place of x, I'm substituting -1. Now be careful. Remember, you're substituting -1, so I'm substituting negative. -1 times itself is 1. 1 minus 6 is a -5. So that's my numerator. My denominator, -1 plus 3, is a -2. -1 and a -4 is a -5. So I want to see if that's going to equal 3 divided by -1 plus 3 is a -2, plus 5 divided by -1 and -4 is a -5. All right. So this becomes -5 divided by positive 10. So -5 divided by positive 10, which becomes a -1/2, right? So this is -1/2. Here, this becomes -3/2 plus a -1, or -3/2 minus 1. But remember, -3/2 is the same thing as the decimal -1.5, and -1.5, all right, I made a mistake somewhere, so let me, oh, I'm sorry, I made a mistake here. -1 plus 3 is a positive 2, excuse me. So that's be a -10, so that's a positive 1/2. So I made a mistake there. And I knew I made a mistake because they weren't going to equal. So -1 plus 3 is a positive 2. So I get positive 1/2 here. All right, so over here, I get, let's see. All right, over here I get 3 divided by -1 plus 3 is a positive 2, right? So that'll be a positive 1.5 right here. So a positive 1.5 minus 1 is going to be a positive 0.5, which is what this is. So those are equal. All right, so be careful. You could easily make that mistake like I did here. So a -1 plus 3 is a positive 2. So you got to fix that on both sides. All right, so that was number 2. So notice that this rational equation had 2 solutions. Let's look at number 3. Number 3, we have this for number 3. All right, so let's go ahead and factor this trinomial, and hopefully the factors will be the same as these. So we get x minus 8, x minus 4, and when you multiply that out, that does work. So let's find the restrictions. So the restrictions, what makes this 0? Well, that's 0 when x equal 8, right? Because 8 minus 8 is 0. That's 0 when x equal 4. 4 minus 4 is 0. What makes this factor 0? I've already taken care of that. That's 8. What makes this factor 0? That's going to be 4. So there are only 2 restrictions. Your LCD has to include every factor that you see. So I see an x minus 8 times. I see an x minus 4. X minus 8, I already have it. X minus 4, I already have it. So there's your LCD. It's just those 2 factors. So now I'm going to multiply both sides by the LCD. So basically I'm multiplying every fraction by the LCD. So I get the LCD, x minus 8 times x minus 4 times the first fraction, x divided by x minus 8, minus the LCD, x minus 8, x minus 4, times the second fraction, equal the LCD, x minus 8, x minus 4, times the third fraction, right? All right, now, okay, so now we're going to reduce. Remember, the whole purpose of multiplying every fraction by the LCD is to get these denominators to be factors of 1s. So the x minus 8's divide out. Now be careful, you have x times x minus 4, right? So x times x minus 4, because 1 times x minus 4 is just x minus 4. Subtract. Over here, the x minus 4's divide out, but you have 2 times x minus 8. So all of this right here becomes just this. So subtract, and then 2 times x minus 8 equal, now over here, all of these divide out, so you see you have factors of 1s in the denominators. So over here, though, all you have is this expression, -3x plus 56. Okay, now let's go ahead and distribute. So x times x is x squared, so I'm going to get this quadratic equation. X times a -4 is a -4x. and then distribute here, I get negative 2x plus 16. Negative 2 times negative 8 is a positive 16, equal negative 3x plus 56. Combining like terms, I get x squared minus 6x plus 16 equal negative 3x plus 56, right? Okay, so let's bring all the terms to one side. So when I do that, now just be careful. You're going to add 3x to both sides. All right, so you may want to do this, uh, physically do this by writing it. So you get x squared minus 3x and then plus 16 equal, and that's 0, you get 56. Then subtract 56 from both sides. You get x squared minus 3x minus 40 equal 0. All right, so now I have this quadratic equation. I have 0 on the other side. And remember, for us, they're all going to be factorable. So I'm going to factor this. I get x minus 8 times x plus 5 is equal to 0. Then set each factor equal to 0. I get x minus 8 equals 0. X plus 5 equals 0. So I get x to be 8, x to be negative 5. So those are my proposed solutions, right? So these are my proposed solutions. But I got to check these proposed solutions to see if there are any restrictions. And you notice that, hey, x equal 8 is a restriction. Now, let me just use a terminology here which you're going to see quite often. So these solutions, those are solutions. Those are solutions to this quadratic equation, right? And the problem though is that well, first of all, x equal 8 is a solution to the linear equation, which is a solution to the quadratic. X equal negative 5 is a solution to this linear equation, which is a solution to the quadratic. But the problem is that 8 is not a solution to the rational equation because of this restriction. And so what we say is that this x equal 8 is an extraneous solution. Extraneous solution. extraneous. An extraneous solution. Meaning sometimes we'll use the word false solution. That's a false solution. It's a solution to this quadratic equation, but it's not a solution to the rational equation because of the restriction. All right, so the only solution, so in the blank you're going to say solution is just going to be x equal negative 5. All right, so that was number 3. Number 4. So in number 4 we have this difference of two squares. So let's go ahead and factor this. X minus 1, x plus 1, which is what we see here. And so the restriction, so what makes x minus 1 equal to 0? So x minus 1 equals 0 and x equal 1, right? So x cannot equal 1. Over here, x plus 1, 0 when x is negative 1. That's already taken care of, and that's already taken care of. All right, so those are my two restrictions. The LCD is going to be each of those factors as a product of each of those factors. So x minus 1, x plus 1. And now I'm going to multiply all fractions by that LCD. So that's going to clear your fractions. So I get the LCD, which is x minus 1, x plus 1, times the first fraction, 4 divided by x minus 1, x plus 1, minus x minus 1, x plus 1, times the second fraction, x minus 1 divided by x plus 1, equal, and then the LCD, I'm running out of room, times the fraction on the other side. Okay, now here's what's going to happen. You got to be careful. All these factors divide out. So you get, if you remember, the whole purpose of multiplying by the LCD is to get this fraction to be a factor of 1, and it is. So I have 1 times 4 is 4. Now be careful over here. See, the x plus 1s divide out, right? But here's what you have. And the fact that that's a subtraction, you need to be careful. You need to be careful. So you're going to put this in bracket for right now. You need to put it in bracket, because if you don't, your signs are going to be incorrect, and you're going to end up having the wrong quadratic equation, because you're subtracting this product right here. So you got to put that in parentheses. So this product, if you look at it, that's a binomial times a binomial. So that's x minus 1 times x minus 1. All right, over here, these divide out, the x minus 1's divide out, and you have these two binomials multiplied together. Okay, notice the x plus 7 I put in parentheses. Now let's go ahead and multiply this out right here. So notice I put that in bracket. Make sure you understand that that's important there. You would have made a mistake if you didn't. So 4 minus in bracket, if I FOIL this out, I get x squared. The outer and the inner will give me negative 2x, and a negative 1 times a negative 1 is a positive 1. Okay, over here, FOIL this out, I get x squared. The outer and the inner is going to be 8x, and then 1 times 7 is 7. Now here's why this was important, the bracket, because now you can distribute a negative throughout here. So you're going to get 4, the opposite of x squared is a negative x squared, the opposite of a negative 2x is a positive 2x, and the opposite of a positive 1 is a negative 1. If you did not put that in bracket, you would not have this correct right here. Equal x squared plus 8x plus 7. Combining like terms, now be careful, combining like terms, I get negative x squared, not positive, negative x squared plus 2x. 4 and a negative 1 is a positive 3 equal x squared plus 8x plus 7. Now I'm going to go ahead and bring the x squareds to the right hand side to make it positive. So adding x squared to both sides, this is 0. I get 2x plus 3 equal x squared plus x squared is 2x squared plus 8x plus 7, right? Subtracting 2x from both sides, combine like terms, I get 3 equal 2x squared plus 6x plus 7. And then finally subtracting 3 from both sides. Notice I'm aligning my like terms. 3 minus 3 is 0. So I get 0 equals 2x squared plus 6x plus 4. And so I'm going to go ahead and rewrite. I'm going to transpose the side so that way I can have 0 on the other side. You don't have to. It's just a preference. Okay. Now I want you to notice something though. I can factor this as I see it. But notice that every term is divisible by 2. So I'm going to go ahead and divide everything by 2. So 2x squared divided by 2 is x squared. 6x divided by 2 is 3x. 4 divided by 2 is 2. And 0 divided by 2 is 0. And what you do to one side, you do to the other. And it's easier to factor this one than it was this one. So when I factor this, here's what I get. I get x plus 2 times x plus 1 equals 0. So that's how you factor this. Setting each factor equal to 0, I get x equal negative 2 and x equal negative 1. So those are my proposed solutions. But I'm going to ask you, are any of these extraneous? Because those are solutions to the quadratic, but are they solution to the rational equation? And the answer is you got to look at this. So notice that negative 1 is a restriction. So I cannot use negative 1. That's a restriction. That's an extraneous solution. Okay? And so the only solution is going to be x equal negative 2. All right. So that was number 4. And then finally number 5. Let's look at number 5. Okay, so I had this rational equation. I want you to notice that to factor this denominator here, I'm going to have to factor out an x, right? So factor out the GCFs. The GCF is x. I get x times x plus 1. And so my restrictions, and I cannot factor the other denominators, so the restrictions, you got to be careful here. So notice that you have in this denominator you have two factors. So if I cover this one right now and look at this, all of you can tell me what makes this factor equal to 0? Well, when x is negative 1. So that was the easier one, right? But you got to also look at this. What makes, if I cover the x plus 1, what makes this x equal to 0? Well, x equals 0 when x is 0. So those are your two restrictions, negative 1 and 0. Because negative 1 is going to make this 0, is going to make this 0. So that's undefined. 3 divided by 0 is undefined. And then 0 is going to make this denominator 0 because 0 times 1 is 0. 1 divided by 0 is undefined. Your LCD has to include every factor you see. I see an x. I see an x plus 1. I see an x plus 1, but I already have it. So that's your LCD. Your LCD is a product now. Make sure you write it as a product, x times x plus 1. So now I'm going to multiply both sides by the LCD. And I'm going to go ahead and actually do that step where I'm going to put that in parentheses. So I have x times x plus 1 times the left-hand side, which is 2 minus 1 divided by x times x plus 1, equal the LCD times the right-hand side, 3 divided by x plus 1. Distributing, be careful, you get this LCD times 2, so you get 2x times x plus 1. This right here is this. I put the 2 in front. Minus the LCD times this fraction. Okay? Equal. And over here, I'm going to go, before I write this out here, I'm going to go ahead and reduce. So the x plus 1's divide out, so you get 3x, right? Just 3x. Okay, now be careful here. You have a monomial times a binomial, so I'm going to distribute. So 2x times x is 2x squared. 2x times 1 is 2x. Over here, all of this divides out, right? So you get minus 1. Minus 1 equal 3x. So you have this quadratic equation. So I'm going to go ahead and subtract 3x from both sides. Combining like terms, you get 2x squared minus x. 2x minus 3x is a negative x. Minus 1 equals 0. All right, let's go ahead and factor. So when I factor, I get 2x, let's see, x, and I need this to be 1, this to be 1, and this one's going to be the one that's going to be negative, and this is positive. And so therefore, when I set each factor equal to 0, I get 2x plus 1 equals 0, x minus 1 equals 0, so x to be a negative 1 half, x to be 1, right? Oops. Did I do this correct? Yep. All right. And so therefore, you need to look at these proposed solutions and you need to ask yourself, are any of these proposed solutions restrictions? Are any of these proposed solutions restrictions? And the answer is no. So I don't have any extraneous solutions. So those proposed solutions are my solutions. The solutions are, there are two of them. Solutions are x equal negative 1 half, comma, x equal 1. All right, so that is solving rational equations. I want you to notice though, in these examples, I went from a rational equation to a quadratic. So you factor this quadratic and you ended up with two proposed solutions. You noticed that in some examples both proposed solutions worked. In other examples, you ended up having extraneous solutions, so there were only one solution in that case. All right. Now there are situations, and we didn't do one here, but there are situations where both proposed solutions don't work. So then you would say no solution in that case. All right. Okay. So that is the review on solving rational equations.